You've probably heard people talk a lot about machine learning and data science, but what is machine learning? Conceptually, it's very simple. Machine learning is all about making predictions. For example, let's say you have a computer vision-based machine learning model that takes as input pictures. Let's say it gets as input a picture of this orange pen, then its output can be orange pen. Or let's say it gets a picture of this pumpkin, then the output of that computer vision machine learning model should say something like pumpkin, and etc. So it's all about making predictions. It doesn't have to just be in images. It can be with any type of input data. Other popular methods are text. So you give in some text, let's say a review, a Yelp review. The output can be positive or negative review. You could also have videos or audio or Excel data. Whatever type of data you want to give into the model, it will make predictions from that model. So that probably sounds like magic right now, right? Like, okay, you're making predictions. How does it do that? It's probably super complex. Actually, it's not super complex. And it turns out that you actually already know the math for the basics of machine learning. And everything beyond that is just extensions of that same idea. So let's look at an example so you can see what I'm talking about. If you've taken Algebra 1, then you already know the basic idea of the math behind machine learning. So to start off, let's recall from Algebra 1 that the equation for a line is y equals mx plus b, where the input to the line is x and the output of the line is y. And so in the case of machine learning, you might want to predict your y variable given the input x. And m and b are what we call the model parameters. The machine learning model is learning what the slope and the intercept should be, so that if you give it the right input x, it'll give you the right output y. In the real world, so I just typed in linear regression here on Google Images, you might have a lot of data. Let's say x-axis is YouTube likes. Hopefully this one is on the right-hand side. And the y-axis is the sales of the product being advertised in that video. We could see, and all the black points are the different data points that you have. And your goal is to build a predictor so that given the number of YouTube likes, can you predict what the sale of that product is going to be? So the way to do that is to use basically some calculus to figure out that this blue line is the best fit for these data points. So this blue line predicts those data points pretty well. It's a good average of those data points. So now if you get a new person who says, you know, this YouTube video is going to get 100 likes, then you could go up to the corresponding Y position and say, okay, well, I'm going to predict based on all the previous data that it's going to make about 12, let's say 12,000 sales, unit sales. And that's the idea of machine learning. So you have the input X, you're trying to predict the output Y, and the machine learning model is what you're doing in the process of building your machine learning model is learning the best M, the best slope, and the best B, the best intercept, so that you have a nice line that's going to make good predictions on your existing data. So just Algebra 1. The process for learning the M and B requires some calculus and a little bit of algorithms, but it's nothing more than that, just a little bit of calculus and taking some derivatives and using the chain rule. So definitely pay attention in calculus class if you haven't already. If you've already taken an entire calculus class, then you know way more calculus than you need to know to understand how machine learning actually works. But at the end of the day, you could just think of it as some math to learn this best prediction line. Okay, so machine learning is not always working on lines though, because in the real world, you can imagine in many machine learning problems, there's not just one input variable. You can have 100 input variables. Let's say you're trying to predict something about someone's social media, then you might have one axis for the number of friends they have, another axis for the number of posts they look at every day, a third axis for the time they spend on each page on average, a fourth axis for et cetera, et cetera, et cetera. And eventually you could have a 100-axis plot. So in mathematical terms, we call that a 100-dimensional problem. But it's basically the same thing. You're just trying to find not necessarily the line, but the curve or whatever shape predicts, or hyperplane, or whatever 99-dimensional shape best predicts your 100-dimensional problem. It's the exact same idea as in this picture, except you just have many more axes, and it's not a line of best fit. It's this big shape that works in this space with 100 different axes. But otherwise, it's the same concept. And the math actually is basically the same no matter how many axes you have, which is nice. So this type of machine learning that we see here is called regression. There's another type of machine learning called classification, which is similar, except now you're not trying to find the shape of best fit for the data, but rather you're trying to predict categories. So you're trying to learn what is the shape that's best going to separate our data. So let's say you have on your x-axis the number of likes of a post, y-axis is average amount of time spent on a post, and then these green dots represent the data, the posts that have positive content on them, and the turquoise dots represent the posts that have negative content on them. Your goal in classification is to learn a line or some shape that's going to best separate these points, so that if you get a new point that, let's say, has an average amount of time spent on it is 0.2 seconds, and the average number of likes on it is 0.2, let's say some different unit here, like let's say in the thousands, then because that data point falls on this side of this curve, we're going to predict it in the turquoise category. You can see that more clearly here. So that's called classification. Again, there's some math involved, but fundamentally it's simple math, just some calculus, linear algebra, and some high school math just to learn those shapes of best separation. So we'll have future videos on MLPro that go into the details of how that works, but just know that at the end of the day, you're either learning a shape that's best fitting the data or a shape that's best separating the different categories of the data so that you can easily make predictions. So I'm excited to go on this journey with you to learn some machine learning. Hopefully this video helped to demystify some of the magic that you probably think of when you hear people say, oh, I built a predictive model. Well, it's not that hard. It's just, line of best fit or line of best separation. All right, so many more videos to come. And if you enjoy this type of content, you can also practice your understanding on MLPro.io, where we have a bunch of different problems, and soon we'll have multiple choice and open-ended problems as well for you to practice your understanding and to become an ML Pro. Stay tuned.